So we're going to kick things off with a kind of 45-minute introduction to what NiFi is, give you a demo, understand what it looks like, and then we'll have a set of labs that you should have received a link to. And we have a couple great experts to accompany and kind of help you explore things. So if you have particular questions about things you want to know, I guess beyond kind of the fundamentals of NiFi, feel free to ask someone. I'll introduce those folks that are here to help me when we get to that point. But at that point, we'll kind of dive off there and just go through the labs and help you guys kind of get acquainted with what NiFi is, how it can help you with Dataflow, and kind of the core principles of it. So my name is Aldrin Peary. I have the sweet little Twitter handle there that is very descriptive. Some additional information about me: I am a developer with Hortonworks. Been working with NiFi for quite a long time. I'm a PMC member and a committer in the open source community. We love contributions and new people to come join us. So if you're inspired and want to throw some new extensions out there, I encourage you to check us out. I'll have some information on that at the end of the presentation. So looking at what we're going to cover, we're going to talk about what Dataflow is, right? Where do we see this? How does it represent itself? What does it mean? And what kind of challenges arise from that? What are the real practicalities of moving things from point A to point B? I'm going to introduce Apache NiFi, why we're all here, to show how it kind of addresses those issues, those challenges, and the thoughts and principles that go into it to kind of accommodate those things when we're looking at dealing with data at large scale in distributed fashions. I'll give a live demo showing what Apache NiFi looks like and how some of that stuff works, how these extensions work, how you can interface with it, real-time command control, the interactive nature of things. We'll talk a little about community, and then we'll kick off the lab and get you started down that path as well. So moving into what Dataflow is. Starts off pretty simple, right? We all see these fun diagrams talking about the Internet of everything, anything, devices. That's what we kind of call things now, but it's always been a problem of these source producers generating information, me moving it across these kind of hidden wires, connections across the air, and it's getting sent to consumers. So this is our typical diagram, right? I move things from left to right. Things get generated. I move them through. They get stored someplace. I do neat stuff with it. If I'm a data scientist, I'm looking for insights. If I'm looking at building a large collection of information, I store them into something like my data lake, throw on the HDFS, any number of places. And we have this nice unifying bar here that kind of makes that all happen. So I kind of posit that moving data effectively is hard. And if you're an XKCD person, you may have seen this comic before, right? So one of the things we deal with are standards. So hey, there's umpteen bajillion different formats and protocols, connections. Maybe we're all using XML, but maybe that schema is a little bit different. Or, hey, maybe we have this schema, we agree on it, but that one team, they don't really know what XML is, and they think just having those little tags there makes it XML and do nothing else with it. So these are all kind of real practicalities, moving beyond just sheer fact of data transport and the technical challenges, and dealing with things like the politics, the personalities, and the associated challenges, kind of the softer factors that go with it as well. This article is kind of showing that, hey, I have these 14 standards and everything's so difficult. If only I had one way to kind of just move all the data around, that'd be great. Introducing yet another standard. And so looking at some of the things I highlighted, here are some of the things we look at and face. Standards, formats, delivery semantics. I want things exactly once. I don't want to lose any data. I don't want to have any duplicates. How true that information is. Is it something I trust? Is it valid? Looking at security, making sure that I have trusted channels coming to me. And then also overcoming security. I have my kind of enterprise set up here, and I only have this one port, and I have to get data through. How can I make that happen? How can I kind of lock down that space while still making it possible for things to move from point A to point B? Dealing with the consumer change, producer change, dealing with the politics, those people, that team, that person. Network conditions. In the data center, things are pretty great. We have really, really fast network cards. Things are moving around pretty nicely. But what about some of those remote sites, even like a retail presence? Connections come and go. Some guy trips over the cord. I lose data for that time period. What happens to that information as well? And then we also deal with things like exactly once delivery. So let's look at this and kind of scoped under a particular use case, right? So let's think of like a courier service. Some place that has some presence, right? I have a store, I take a package to it, they do some transactions, I need some boxes to put things in. I need mobile devices to kind of scan things as packages come and go. This particular store is rolling up to kind of a regional distribution center. We have these nice physical analogies to kind of the flow of data, right? I have these stores that are taking a single package. They move up to a distribution center that might be regional. It has a certain set of places that it handles. It works on kind of orchestrating things at the next tier. And I have my core data center, my headquarters, the nervous center of my entire enterprise. And they're kind of working in concert with all of these different things. External from all of this is people and delivery routes. I have my trucks, I have my deliverers. They have their own sets of devices, communicating information. I've dropped this package at your front door. You weren't available for pickup. And we want all this data to kind of come back and do things with it. So looking at each of these particular components in our kind of graph here, they have different formats, right? Looking at that mobile device that's doing scanning, maybe it has some kind of older format, binary in particular. I have to adapt that. I'm gonna get something that's usable and store it someplace so I can get some neat insights to look at where our efficiencies are and where items are at, to do some neat maybe machine learning or data science on top of it. My registers are looking at transaction information. Sometimes this is a very complex format like CSV and new and up and comer for encoding our information. So these are kind of all the real things that we look at just within our organization. Sometimes we have the benefit of saying this is the format we use for everything and using only that. But those cases where we don't, how can we be adaptable and make change? So we've started collecting this information, and that's awesome, right? We're getting all the data all the time. We're moving it from the edge all the way to our data center, and we've collected it. Well, now there's other things that kind of come into the picture as well. We're looking at bringing things to our distribution center, and maybe we're doing some things there locally to kind of drive things a little closer to those stores, understand logistics, how I can move things from point A to point B. We're doing higher level business functions then, looking at our core data center at headquarters, talking to something like a Kafka, a message broker, sending out to a lot of the fun processing frameworks. As NiFi, we are feeding the beasts, right? We are giving this massive data, getting it ready in the format it needs to be, so something like Flink, something like Storm, Spark, what have you, can do its job and give us those neat kind of models. So that's pretty cool, but again, now we've introduced more complexity because there are certain descriptor files and types that they're expecting that they want us to come in through. Kafka has certain requirements on how big that data can be. It has certain constraints on also how big the data can be, right? And so, that works great for my streaming stuff. But what about my batch kind of things where it's getting stored long-term, HDFS for my kind of batch processing? How do I remedy all that? Different formats of data, different structures. And so, kind of revisiting these same topics, we're now scoping things internally, right? We are just working on moving things within our own organization, and we have these challenges. Not everything speaks the same language. We get pretty close, so there's a few things that are kind of best in class in terms of formats, but then digging a little bit deeper into that, there's schemas that are embedded in there, there's protocols that are embedded in there. And so we kind of keep digging a little bit deeper down to the rabbit hole. Oh, that's right, I'm a courier service. I'm big time, so I go international. I'm not just simply moving things within my one state, within one country. I'm moving things across the world. So I get these different pop-up items here where I have this very similar structure that's kind of orchestrated from a higher level view. I'm dealing with then other business partners. I work on logistics with other partners that provide me cost savings. So how can I share data with them, move things between? And so again, now we're looking at these same things scoped globally. And that presents some interesting challenges as well. The ideas of policies and politics get a little bit different. Looking at cases of like China, where I can export a lot of information, but GPS information can never leave those borders. It has to get scrubbed. So now we're taking the same data, but we're doing certain kinds of enrichment or actually filtering of information that can't leave, just so that we're playing the game appropriately in terms of moving data around. So we look at this. We've seen a couple of these so far. We're talking about lines, right? Pretty awesome. But when we look at these diagrams as how data traverses around, how our big data ecosystem looks, it's these lines that kind of unite everything. So we found our big gray tube, the Airnet, which is awesome. It's connecting all these devices, everything, anything, and all the stuff in between. Then we have these things that are inter and intra connections within our organization and our enterprise. So I'd ask you to then kind of think about what this really means. So looking at the anatomy of one of these lines, let's consider the Airnet, right? What this is really saying when we think about this is that there's kind of three components. We have the beginning, the middle, and the end. The beginning, things don't just magically show up on this line. Something puts it there. And so we have different applications, scripts, where I'm managing this one format from this one device, and I'm passing it on to this line. That's great. And then there's some kind of physical transport that moves from point A to point B, and then drops off to the other side. And of course, this line doesn't just offload things. There's something on the other side that's listening to it. It's saying, okay, I got this stuff. It's this format. It came from these people. Can I trust it? Well, it has these credentials. Things look good. Let me come off of there. And so there's a lot of stuff that's kind of touching these items from point A to point B. So we start digging a little bit deeper. Well, looking at these devices, how often is it that we have just direct point A to point B for everything? There's typically other stuff in between. I want to have my core data at headquarters cordoned off from the rest of the world. I don't want it publicly exposed. So there's proxies, firewalls, things to navigate. Certain protocols are available going across certain ports that IT has signed off and said, okay, you have the rights to use this one. It's secure. It's for this application. So how can I filter everything down to that and understand how everything's moving through there? So I get this kind of line inception, right? We're going deeper into the data flow dream. There's these other lines that are taking place in these lines where we have copies of data that are getting created to make the gap from one point to the next. The Airnet has now, kind of gone a little bit deeper and has other devices and other scripts and applications that are taking the load along the way. One final step then, well, guess what? Each of these lines inside this line, it also has parts, and who knows what those things are doing, right? And so we're making all these hops from different message brokers to different systems, to different scripts. They're all doing their little bit of magic on it, and it kind of becomes hard to reason about where everything's going and how everything's being touched. So we get this, nasty recursiveness with recursion, with our lines, right? And I was trying to find a good joke about recursion, but didn't have such good luck with that. So this is kind of some of the things and pain points that Apache NiFi came about to solve. When you talk about refactoring, right, you talk about code smells, right? NiFi has a similar kind of thing. You're talking about data flow smells, right? And if we think about this in plumbing, as long as the plumbing's working, everything's great. But if it doesn't work, you start smelling things, there's backups, things aren't so good. And so there's some things that we try to address, right? These proliferation of scripts and systems. As long as data flow is going, everything's great. But when things break, which one of the lines at which level is the thing that broke? What data am I not getting? If there's a system that's been compromised, can I still trust that information if it's getting pumped to a single topic, a single queue? How can I understand what's going on there? And so here are some of the principles and features that NiFi takes care of and provides as a framework. We're looking at guaranteed delivery. So in general, NiFi will provide everything at least once. So depending on protocol, we can give stronger semantics, but again, it depends on what kind of systems we're integrating with. Data buffering's big. Dealing with that network condition, right? We're thinking about times where I have these devices that are out in the world. If I'm thinking my courier with his handheld, taking care of packages, well, at some point, I may be driving through an area with spotty cell reception, and I can't send those things now. So if I have a library on there that's trying to send information back, and they can't do it, some things matter to me. And one of the things that we want is to have all the data all the time. I never want to lose anything. But sometimes that's not possible. We have smaller devices, smaller storage, smaller processing power, and their core function is to do something else besides send their metrics back. So how can I be intelligent about what my data is doing? This gets into things like prioritized queuing and this pressure release. So that in the worst case, I can say, I can't get this data back, but I'm going to hold on to the stuff that says this package was delivered, and maybe less about the GPS of where my driver or truck has been currently. We get into things like data provenance then. Data provenance is kind of the fancy way of saying that we look at lineage, a chain of custody, understanding where data's come from, what journey it's gone on, and who's touched it, what systems have touched it. NiFi is kind of placed at an interesting position where it sees access to a lot of these systems, right? Doing integration, we touch a lot of systems, we talk to a lot of systems, so we get some unique insights into how things are moving about. We have to support push and pull models. Your organization, you as a person have invested resources, whether it be money, whether it be your time, in specific technologies, applications. How can I make use of that? I can't always force things to pull from me or push to those items. So let me do both. Obviously, when we're dealing with data, it's all very important. So the things that we do bring in, let's ensure that we have a resiliency to those items. So let's have a way of kind of tracking where data is in the flow. So if the power goes out when I'm processing that one important customer record, I can resume from that state and trust that my data is good. Where NiFi came from, dealing with those kind of bad smells of data flow, I want a way of kind of interacting with this system and reasoning about what my data flow is doing. One of the things that you'll see, and I hope to impress upon you, that's important to us as a community, is the idea that we're empowering people to make changes to the flow. We're dealing with folks that are operations focused, and they're awesome at making all the systems work and talk together, but maybe they don't get down into the XML descriptor files or these properties files. So how can we give nice indicators of what the system's doing, give them stats of how we're performing, and empower them to make changes without having to restart 5 different computers or something like that? Do things in real time. When I'm sending data to that one system on that one team that can't quite get their act together, I don't want to bring my system down waiting for them to take it. So let's give the operators a chance to do something with it and ensure my system stays up. Again, kind of fitting in with a notion of dealing with the existing infrastructure that's there, we're designed for extension. We give a lot of nice utilities out of the box with a standard distribution of NiFi, but you have inherent processes, formats, protocols, schemas, all those things we talked about before that are specific to your organization. So how can you build a NiFi as a framework? How can I get all this great stuff that deals very well with the notion of data flow using some of the custom stuff I've done already? Let me make use of the Java ecosystem, make use of libraries I've created to create some extensions that fit in the context of the NiFi framework. On top of that, of course, if we're talking about scale, one instance isn't typically enough. So clustering comes into the picture then as well. How can I provide lots of machines for this to run, do large amounts of data processing, and kind of have a central view into how it all works? Something that was recently announced and talked about in the community is under current development is a sub-project called Minify. So the way I like to kind of posit this is say, NiFi, I live in the data center. I will give you a server or a group of servers, and NiFi is going to use all those resources, consume that server. Its core focus is data flow and the functions that come with it. Minify is not the star of the show. We're working in constrained environments, things where the function isn't just data flow, it's doing something else, but is generating interesting information. It allows us to kind of push out to where that data is created and create a rich kind of trail of information from where it starts to where it's consumed. It also allows us to establish some neat bidirectional communication. Let me take these awesome models I create with my huge 1,000 cluster Spark, take some of those things, send it back to the edge and say, I actually don't care about the information because I'm not using it. Let's be more efficient and smarter by having a two-way street. So let's talk about our courier service again, and then use some of the stuff we learned about NiFi and how this might work. We're looking at things like client libraries that talk the secure site-to-site protocol of NiFi. Dealing with Minify, again, I'm a gateway server. I do a lot of transactional things for my company. I just want to kind of forward this information along. It's feeding something like a server cluster in my distribution center. That's dealing with kind of routing information to the appropriate systems that need it, aggregating things, rolling them up, defeating information that may not be necessary, kind of enriching as needed with the context it has at that scope, and then feeding maybe even larger cluster back at headquarters that's feeding those big beasts of analytics systems that like to do interesting modeling for us. Out at the edge, on our routes, we may have things like client libraries, again, on those devices, or a Minify instance on the truck. Again, this gives us a very unique insight so that when that scan happens on a package or something happens there, I can start the trail of that lineage where data's been from the point it's created. We're getting as close as we possibly can. And so kind of looking at this from just the management of data flow, you look at this kind of bidirectional relationship where Minify feeds into NiFi, and NiFi learns things from these analytics systems and then feeds back into Minify. And this goes all the way from that edge, your Internet of Things devices, all the way through to your core data centers and back again, sending data and events into the cluster, and then sending context, commands, information back out to the edge. So for some context, NiFi is based on FlowBased Programming. FlowBased Programming was created by John Paul Morrison in the 70s. And so we won't go too deep into the flow-based programming terms, but looking from the NiFi perspective, going to establish some vocabulary effectively as we start going through the particular items in the UI. The kind of core unit and core item of work or message event is this flow file. And it's these objects as they traverse through our processing. A flow file is a bit misleading because people think about streaming, right? And they think about flow files and ask about, well, how can I handle this kind of data? And the best way to think about a flow file is that it's kind of binary bits, right? We don't really care what's in there. We have a set of headers and attributes that describe what this file is and the set of data. And they can use that to route and have different processing that occurs. What drives most of the processing in our system are flow file processors. And these are black boxes of functionality, very functional in nature, right? I take data in, I apply some function to them, and something goes out on the other side. This kind of falls under the umbrella of simple event processing. And nothing necessarily has to be simple about it. When we talk about simple event processing, we talk about this very functional nature, right? We're not looking at windowing or aggregates or these rolling buffers of information. We can do some very complex things here. There has been some community talk of people doing very intensive geospatial interpretation and enrichment of images, right? The library and stuff that they have that does this is very functional. It may take a lot longer and use a lot more resources. Very complex, but in terms of its function, it's input in, something out. Connections then unite these processors, and they kind of create this nice graph of processing from one processor to the next and help guide the path of a flow file as it moves through our system. The flow controller is kind of the orchestrator of all of this. It sits above, takes care of handling the resources that are allocated to processors, how many tasks they're allowed to run with, concurrency, those types of items, and then manages the flow files as they make their way through, looking at that transactional nature in case something bad should happen, power goes out on the system. Process groups are kind of nice abstractions of these things. So if I think of several of these kind of functions I'd like to do, let's say I have a kind of key pattern for doing enrichment of geographic information. And it's several processors. I look out to some service, I adjust some attributes, apply some things to it. I can say, okay, well, let me have a process group that takes a flow file in, does all the stuff behind the scenes, and then sends something out the other side, right? So it's this black box where I have a higher level abstraction of that core functionality made up of these kind of units of work done through processors. One nice thing to know is that NiFi and flow files are data agnostic, which everyone likes to hear. We're not coupled to any particular format, any particular system. We can handle it all. That's true, and NiFi does. We don't care what that payload is. It's bytes to us. However, if you're dealing with that data, you inherently do care what that data is. There's certain business logic, rules, processing you want to apply to it. And so we'll say, okay, we're data agnostic, but we're looking at doing processing. We also want to have a way of interpreting that, handling it, extracting meaning from it when we choose where it goes on its life cycle. So we have the processors and extensions that work with those things. One of the things that I like to refer to frequently is this robustness principle. And simply it says, be conservative in what you do, be liberal in what you accept from others. So as far as NiFi is concerned, you want to send some bytes to us, we'll create a flow file of it, however that's kind of packaged up, and then we'll do things with it. And then we'll be very strict in terms of what we send out to the systems that need it. We match that kind of agnostic blob of information to the right format, protocol, schema, whatever it is of the system that we're feeding. Let us take care of that integration work and match impedances from point A to point B. I mentioned before that flow files are this kind of HTTP-like data. Here's a quick little diagram to show that. So in this case, you look at the HTTP data on the left, right? We have a set of headers, what the status code was, timestamp, what the web server was, some payload. NiFi is very similar. We have these key value pairs, these flow file attributes. Some are standard that come with the framework that it takes care of to track things, monitor those objects as it goes through the system. Some are added by users and processors. If I extract information from it, if I learn things about the data, do some heavy lifting, a lot of times I can learn everything I need to know about that one piece of data up front. Oh, I see this as XML. I see it's referring to this kind of particular type of data. Maybe it's sales data. It's going to this system. So I tag those things up. It's going to sales. Here's the associated attributes with it. Let me just do simple routing on its way through. In the content then, we have a binary content, right? There's a little asterisk there. It's quite small. But there's some neat things that we do in terms of optimization of that content that we can take advantage of given our architecture, which we'll talk about shortly. Like now. So we're going to talk about architecture. First of all, the crash course is kind of structured just to get you acquainted with NiFi. We won't have a chance to kind of go into customized development, but I wanted to highlight what these extension and integration points are. So we have the processors I've mentioned. There's also reporting tasks, controller services. These are all extensible. These help to let you bring your custom functionality you have for your organization, wrap it in the framework, and make use of those libraries, and get all the other stuff that comes with it for free. So that's very cool. The REST API, which we'll show in a little bit and highlight, is what drives how NiFi works. And so that REST API, in terms of dog fooding, you can't do much more. So the same thing that drives our whole user interface is completely available to you as a system, as a user, to pull information from it, stats, processing, understand how things are looking at, get particular messages about errors that may be occurring. And we can pull things into systems, right? Our monitoring systems, understand how our flows are doing, to give our ops folks some additional tools to be very effective with their data flow. The architecture, I have another asterisk. There's lots of caveats as I go through this presentation. This is how things stand right now. So the version that you downloaded for this crash course and what you would get from the Apache site right now, this is how things are structured. We have a big 1.0 release that's coming out. It'll be our first major release since being in the open source. And it's going to change how it is to get rid of this kind of single point of failure model. To talk about this, though, we're a little bit different. So when you think of a lot of the kind of big data systems, you are thinking of tens, hundreds, or maybe thousands of machines if you're doing a lot of data. We don't take quite as much, right? We're not long-term repositories. We're about taking data in motion, having some context that's configurable for how long you want to have archives of that information to be able to look at what happened. And so we'll see here that one instance of NiFi runs in a single JVM. At that JVM, there's a web server that's exposed. That's twofold, one of which is serving you that UI that you'll see, and the other of which is serving that REST API, which our UI takes use of, and it's also available for you as consumption. Sitting above that, below that, is the flow controller. And that flow controller, again, as mentioned, is orchestrating everything. It's taking care of the resource allocation for all our processes, our extensions, our components. And it's moving things from point A to point B as we go through our data flow here. This all sits on top of 3 repositories. The flow file repository, these are those events that go through there, attributes of those pieces of data as they move through, understanding that metadata. Think of it as the stuff that's on the outside of the package. I don't care what's in that package necessarily, but I know where it's going to, where it's been, its inherent tracking number. There's a content repository, which there can be multiple of these, multiple volumes to exploit parallel writes and reads for speed. And then Provenance repository, also able to have multiple volumes associated with it. This stores all that event information that's going through, what things have touched the system, what kind of insights I can get in terms of how my data is traversing. This model then kind of moves to a very simple kind of clustered model, again, for our current architecture. At the top, you'll see that we have this master, this NiFi Cluster Manager, or NCM. And you'll notice that it doesn't have that flow controller in there, and it doesn't have the repositories. Right now, this is just an orchestrator of these nodes. As it stands now, I work through that NCM to create a flow, and that flow is replicated across all of my individual nodes. So the one thing to keep in mind is that we partition data, right? Our kind of processing path is the same across all of our instances, and that data gets partitioned across them. So data enters and makes its way through. One of the things that you'll notice right now is that, hey, doesn't that NCM look like a single point of failure? And you'd be correct. It is right now, and that's one of the things that's being worked on for 1.0. The single point of failure, though, is limited to changes to the flow. Should that system go offline or be unavailable, something should happen. All the nodes will continue to process as they're configured. Nothing will change there. They continue to work. I just don't have the ability to update my flow while that's unavailable. Again, the work that's coming out with the 1.0 release, which will be coming up in the next few months from the community, will kind of remove this kind of issue and allow things to continue on. So we're going to get a little bit deeper nerd here when we talk about the repositories and some of the things that we can do in terms of how we're efficient. And given that we're in one JVM process and on one machine that allows us to exploit things, you know, think of all these processors as being hops on those lines, right? We talked about those lines earlier, where there's inherently that app, there's that script, that program, talking to some imaginary line that moves things from one point to the next. So from this, the flow files primarily live in memory. We can support arbitrarily large numbers of them. That's perfectly fine. If there's issues where we have too many events on a given connection between two processors, we can start swapping those things out to disk, right? So if I get a huge influx of lots of really small files, I can support that. That's fine. And I can configure that based on my system and what resources I have available. So it's something to show. I have data going into one of my processors. In this case, this is doing a route and attribute. So as I mentioned before, we try and do the heavy lifting up front. Let me realize what this data is when I receive it, tag it up, learn some things about it, and then start sending it on its way. So in this case, I may have gotten that XML file I mentioned earlier, and it may be transactional data. And I say, OK, this is going to sales because it's transactional data. And I route it on its way. So I mark up that particular flow file that's coming through there. I generate a new flow file that has this attribute, but it's still pointing to that same content. So even though the flow file may be marked up and changed, and it's going down different paths, I'm still pointing to that same content. And as long as I don't change that content, it's pointing to the same content all the time. One of the big wins for this is if I think about my data touching down the system to be filtered out or scanned or something like that, just dropped if it can't go to a particular system, I don't need to create duplicate copies of data, incur a network hit to send someplace to evaluate this. I can do this all in Flow. Or if I'm feeding multiple systems, I can read from that one location, stripe it out, send it on its way to all these other systems that need it. So we're being pretty efficient with those items. Copy on write is nice from the standpoint of robustness. So this is how our content repository works for this one. So let's say I'm doing something here. In this case, I'm showing an encrypt content processor. I bring data in, and then I start writing, right? I throw some entropy in there, add some additional bits, make it a little crazy, make it jumbled. Cool. So it's coming through here. I have that flow file coming in that's pointing to a content. So what happens here is I create a new content claim in my content repository. And what I'm saying to it is, OK, let's start writing here. So guess what? If during that unit of work, the power goes out, the system messes up, something bad happens, I still have my original content. I haven't lost it. So that's really nice from the standpoint that if something bad happens, I can resume where things left off. That session's never committed. So I pick up where things left off when the system resumes. I see, oh, flow controller says, hey, there's a flow file waiting to go into this processor. Let's try that again. I can move on my way. So we're going to switch over and do a little bit of a live demo here. So what I'm showing you now is a live instance that's running on AWS. In terms of NiFi, as you'll learn, doesn't matter where you run, on-premise, on a laptop, on a Raspberry Pi, smaller, bigger, whatever. Perfectly fine. All that we really need is a JRE 7 or higher, and then we're good to go. So what we're looking at now is a live flow of information. So zooming out here, I can see that I have all these sources. And then they're feeding another processing cluster here, sending it on its way. So in this case, this particular organization is a little confused and likes to get into a lot of things. So we're getting all these different sources of information and different types. So if you look here at things like movie data, and we're dealing with databases, syslog, network traffic. Lots of fun different types, right? All these kind of different formats, things like that. So we're doing this problem where we have all these producers that are generating different types of information with different volumes and velocities and kind of bring them all under management in one place. So as I mentioned before, and we talked about in that vocabulary slide, these are process groups with these dark gray outlines, dark bluish gray outlines here. And these are kind of the abstractions, right? So we're kind of boxing up what it takes to bring one of these sources into NiFi into one place. So if I want to bring ingest of this type of data, I can use this processor group to kind of repeatedly do so and abstract away all of that and kind of have a neater presentation. All the details are kind of inside. But if I want to see what something's doing, I can start digging into one of these. So if I look at something like the Twitter data, I can dive in here, and I'll see a nice collection of processors. So at the top here, you'll see that there's several instances of this get Twitter processor. In this case, we're talking to the Twitter web service and making use of that Hosebird client that Twitter provides to bring a sampling of that data into NiFi. We're also making use of some of the other endpoints that are available in terms of looking at filtered ones. So finding about tweets that are addressed to Apache NiFi so that if we want to engage with our community and learn things about them, we can see that information comes through, tag them up appropriately, send down a certain data path. But otherwise, just let it continue to go on given place where it's going through. These all feed into kind of our first realization of this data. So working with this from an operational standpoint, I'll see that, hey, Twitter tweets come through JSON messages. Okay, well, that's cool. So let me start dealing with that. So if I look at configuring things, I can start working with the properties that are associated with this. And so if you're a developer, you can kind of think of the processor properties as being along the lines of the arguments I pass to a method, the parameters I'm passing in there. And these come in two forms. The ones that are in bold are the required properties, right? These are things the processor needs to inherently work and carry out its function as designed. And I have these light ones here that are optional properties. In this case, this evaluate JSON path processor is very similar to XPath if you're familiar with it, but if we're working against JSON data. And what I'm doing is I'm extracting these attributes, right? I'm learning everything I need to know about this message in terms of where I want to go to up front. So I look at this and I say, okay, well, let me find out what language this particular tweet's in by selecting this $.lang field. Let me get the handle of the screen name. Let me get the text that was there, any retweets that happened with it. Let me just get this nice metadata, promote it up to top attributes, again, that are living in memory for quick access, quick scanning, making routing decisions, and send the information on its way. So that's pretty good. We can configure one of those and send things on its way. So again, all these things are kind of happening in real time. All the data that's going through there, I can see that in the last 5 minutes, I've dealt with approximately 25,000 tweets that came through. So that's nice to know, understand how I'm performing. And then I can start doing some routing, right? So I've kind of stamped this data as it comes through with my metadata to understand what it is, what it's representing. But I have a new team, and they want to do some crazy data science stuff. They want to do some analytics, understand sentiment of how people feel about Apache NiFi. So I want to make a change now to kind of feed them so that they can do their job and kind of play around with things and understand how the data is working. And so with this palette in the top left, I can click and select this processor and drag it down here. And so they're weird, they're data scientists, but they also care about security. So they want things encrypted to them, and I want to pass these kind of smaller messages across Kafka to them. So let's look at something like encrypt content. So I can do a search here, find the processor that kind of looks like what I want, and so here's this encrypt content, which is great. So let me grab that guy, add to the graph, and so I'm going to start routing this information that I found to be tweets that are coming through here, and send this over here. So things that match on these fields I'm looking for will get sent through. And so if I refresh, what I've done is I've started forking a copy of the data, right? So when I'm talking about a copy of the data, I'm talking about those flow files, a copy of those events that are going through my system that are referencing that same content on disk. So I'm not duplicating data, but I've created a fork in my path. Data is now going down two paths. My main processing line that I had set up before, still running, everything's great. But now I'm also queuing up information ready to go to my data science team so they can do some neat stuff with it. And again, I said their preferred mechanism for receiving this stuff so they can feed one of their storms or sparks will be something like Kafka. So let me look at a Kafka topic here. So I want to talk about Kafka. Search for that. Okay, I see a couple here. There's one that's get Kafka, put Kafka, right? I can look at one of these items here and get a quick little description of what that is. So let me add this to my graph. And I will connect this here. And anything that's successful will get sent on its way. And anything that fails, we'll try again if there's some kind of weirdness that happens. And so this is kind of ready to go. So I think I have this path set up, but there's these little yield signs here. If we kind of zoom in and look at what's going on. And that's just saying, oh, your password's invalid because password's required and I didn't set one. Well, thanks for the information, NiFi. I'm going to fix that. So let's look at configuring this particular processor. And so in this case, I have a mode that's going to work in. I want to encrypt this content to send it on its way. Awesome. That sounds good. We'll use something simple here. We have a lot of crazy options here to kind of tune exactly how you want your encryption to happen. We'll make use of one of the simple ones here with the legacy. And then we will set a nice, we'll ignore this nice warning here too, where we're kind of shooting ourselves in the foot, going with a weaker security. And we'll set a very secure password because I've disabled all these options anyway, so I need a strong password. So we'll have password. Awesome. We are doing great. So now that yield sign where something was wrong has turned to this little red square. It says, okay, I'm good to go, but I'm not running. So that's good. We're probably ready to go. But those data science people, they're always trying new things. And next week, there'll be a new processing framework or 3 that they want to try out. And they'll probably change all their infrastructure and kind of get things revamped again. So I don't want to bring my system down, right? We have that problem where we have that team we can't really trust, or they might mess things up. So let me kind of find a way here to configure what this buffer is going to be, what I'm willing to hold in my system to give them. So I can configure the individual connections as well, right? those lines we were talking about earlier, here they are in NiFi. And so in this case, we're talking about back pressure and pressure release. And so we're talking about real-time kind of analytic platforms. If these files are older than 10 seconds, do they have a lot of value to them anymore? Probably not. We'll call it 10 seconds. We'll hold on to 10 of that for that topic. Anything else will get dropped from the flow. We'll also then prioritize information when it goes down this path. So when things start getting purged off, we'd prefer to have the newest flow file first get sent through, right? Things that are older inherently mean less because we're looking at this real-time stream of information that's going through. So I'll apply that, and I can start kicking off this processor. You'll notice here I didn't set any kind of configuration on that particular connection here. There's just data queuing up, getting ready to go down this path. And so the data, again, is not creating duplicate content. It's just cheap pointers, those flow files, those events going down the separate path. So let me kick off this process, and encrypt content's going to do its thing, and it's going to move through here. And I have a bound buffer, all right? If I have this configured to talk to their Kafka topic, and it's working, great. If there's any issues, that's fine too. I'm not going to lose any sleep, and I'm definitely not going to call in at 3 o'clock in the morning because they decided to change something on the weekend because they thought it'd be cool. That's pretty fun. So the data comes through here, right? Processing's still going. It reaches this part here where it exits out of the process group and gets promoted back to the top level of the canvas. And so you'll see this, that I'm sending it on its way then, right? In one case, I'm sending it off to an analytic cluster using our site-to-site functionality to send a processing group to something like Spark where I can pull from it, right? They don't want the information pushed to them. They want to get it from you when they're ready. I also can then send this to my processing hub, right? Again, using site-to-site functionality. I'm trying to get some of the similar semantics I have in terms of security and event-level filtering in between instances, right? When I'm making that hop between machines. How can I handle this? So this allows me to have access control into what machines I trust, right? If I'm feeding things from my store to my retail center to my distribution center, all the way up to my headquarters, there's different permissions, right? If that store gets sold and someone else takes the equipment over, I don't want them talking anymore. Let me just blacklist that particular client. Don't let them send information to me anymore. So this is all fine and good, right? We set up Dataflow, we've made changes, but we want to learn more, right? We want to understand how things are really traversing, how things are working. So let's go revisit this guy again, right? We've set this stuff up, things seem like they're okay, but I want to understand how everything's traversing. So this is where the idea of data provenance comes in. Where does the data come from? What's touched it? What's happened with it? What does that look like? And so if I click on my icon up here for my data provenance, I'll get this nice log of information. And so at first part, it's just kind of a pretty printed table of information we typically see in logs. So let's stop grepping through logs and doing that thing, right? When something breaks on my system and something's not quite right, the first thing I do is start grepping. Well, let's get rid of that. So let's look at these events that are coming through here. And so in this case, you'll see a series of events here. I'm receiving things, right? So for the particular component, it's this get garden hose, right? It's sampling that Twitter data across that get Twitter component type. I can look at the information associated with that. So I get some nice details in terms of what's happening. What time did this happen? How long has this current lineage been going? In this case, it was less than 1 millisecond. It was very quick to receive that message. What kind of type was it? It was a receive. I'm bringing data into my flow. What's the UUID associated with it? What's its identifier? Where did it come from? The transit URI. Well, I know exactly that it came from this particular endpoint as part of that Twitter service. And I've learned some things about it too when I bring it in. Inherently, I know that it's JSON data, so I'm going to tag it as such. Put a MIME type on there. There's a file name that was associated with it. So that's all fine and good, but I kind of want to revisit what I was doing before, where I was making this encryption stuff to see how that's working. So let me dive down on one of those particular items and look at the data provenance for this particular component that's coming through there. And so now I'm kind of constraining my search to this particular ID, this particular component that was doing things. And so again, I'll see a similar list, right? And I can start digging in here, right? So this one, if I try and reason about what's going on, the type that happens in this case is content modified. Again, that makes sense. I'm bringing data in, I'm adding some entropy to it, putting the bag, shuffling it all up, sending out the other side. Okay, that makes sense. So let me look at one of these events. And in this case, I can look at the content. And so remember before I talked about those input claims and output claims? Well, in this case, I'll see that my initial content that came in was about 3.5 kilobytes. And the one that went out was 3.53, right? I'm adding a little bit of noise to the system here to kind of encrypt that information. So let's do one better, though. Let's see what this was looking like when I was coming in before I made my changes. So if I hit view on this content, let me try another one. Oh, let me first disable my pop-up blocker. The extension for NiFi that does pop-up blocking, and getting around that will come later. Sorry, different machine. So let me go back in here again and revisit my friend for data provenance. Okay, so let me grab another one of these events and scope it out. So let me view one of these guys. And now pop up this blocker disabled. I get some nice content. So let me look at a formatted view of it. And again, I said it was JSON data. And I don't know if anyone's ever dug around with what the Twitter API was sending you, but there's a lot of information here that I don't really care about, right? We get 140 characters. Well, there's URLs in here, there's colors in here about the people's profiles and stuff like that. And again, let's talk about defeating information that's not important to us. We were extracting the things out that mattered most, who our user was, what the message was, and we're putting those to top-level attributes so we can kind of do some interesting evaluation of them. So we see a lot of noise here, right? But the main thing I want to see is that, hey, I'm telling them that I'm sending them encrypted information. Let's verify that. So let me look at the output claim that comes through there. So it's going to try its default rendering here, and there's going to be some crazy bytes and stuff. So let this load. And then let me go check out a hex view of it, right? So this is the output claim, right? I put data into that encrypt content processor, and then on the other side, noise came out, right? And there was a lot of stuff there about URLs before when we saw it. Now there's lots of random noise, right? So I think we're doing a pretty good job here. Not a security expert, but we're giving a good faith effort. Poor password, but we're at least adding some noise to the system here. So that's great. So I've done all this work now. And it's great to see how this is all behaving, but let me start digging in a little bit more. I have this log, I can see the content, that's cool. Where kind of context clues are there? So I can click on this graph icon on the side. I get this trail of information. So if I zoom in here a little bit, I'll see this path, right? And remember we're looking for at that receive event? Well, here I see an event where it came in. And in this case, I received information from that. I can click on any of these, look at their details associated with it, kind of understand each step of the flow, how things are working. And then I see these clone events, right? I was talking before about going down different data paths where I have different destinations for the same data. So let me start expanding out. Let me understand where everything's getting touched. So here in this particular case, the yellow dot will show us where it's at. This is this content modified, right? The encrypt content processor. This makes sense. And remember, what we were doing with this, we were sending it on to a Kafka processor to send it on to another system. And then after this, you'll see this expire event, right? So if I look at this, I'll see the details for that. And it says the expiration threshold was 10 seconds. OK, not only do I kind of see in the UI that the queue is never getting too large, I also see that, hey, I have an exact level event when this is getting dropped from the system. That's pretty nice. On this particular path, then, I can also start looking at these download events. So remember, I was showing you the content to kind of show you that I was doing a good faith job of doing encryption of that data as it goes through. Let me start looking at these. And so one of the nice things that we realized with NiFi is that if I download or view that information, I inherently have a copy of it. It's left my system. I could copy it. I could save it someplace. So you're thinking about things like compliance and auditing where people are touching information. I know that when I have my system secured and have credentials associated with it, I can see who downloaded it. So if I look in here, you'll see that, hey, there's a download of input content requested by me. I'll see my name there. So if I shouldn't have something I'm pulling copies of information off of, it might be interesting to know what I was doing with it. Meanwhile, you can kind of see the production path that we had before, right? The other information was going through unchanged. This wasn't the branch that we made off that data flow. I can expand out here, right? This particular path has sub-branches that are associated with it. This information is getting forked off in different places, getting sent to other consumers, getting expired off in its own way, right? All using that same content, except for when there's a change to it. One nice little kind of nicety that goes with it is that I can also kind of get a quick feel for how this is all taking place relative to each other. So I have this slider in the bottom left corner here. And I can see that, hey, I received this event. Well, that's nice. And then soon after that, I can see that, hey, my main processing is going very quickly relative to everything else. And as I slowly go on here, I can see how the rest of the data is traversing its way. There's some expiration events for that kind of production flow. And then there's that longer process, right? I had some stuff that was buffered up there, waiting for that content to come through. And then that got expired off when I was waiting for Kafka to be online. And then my download events come much later after that. So it's kind of a nice tool set for people to realize and reason about where the flow is going, who's touched it, and how it's been handled. So digging back in here, there's some other nice tooling and stuff like that. Let me do a quick time check. Okay, we're getting pretty close to our slot here, so I'm going to try to wrap things up. We'll dig into more when we get into the crash course. If you have some additional questions, we can get into the UI and those types of things. And we'll expose some more of that through the labs that are set up as well. Just a quick plug, if you're interested in this or other kind of streaming and data flowy type things, right? Moving things from point A to whatever letter you care to do so. We're hosting a Birds of a Feather session tomorrow evening at the conclusion of Summit. It may not be as fun as, getting to go home, but we're pretty fun guys and gals, so come and check us out. We'll have a good time, talk about Dataflow, NiFi, all that jazz, hear use cases, and answer more pointed questions. So encourage you to come out and join us for some deep nerdery into Dataflow. So kind of looking back at what we've learned over this presentation, why NiFi? Well, one thing I hope to impress upon you is that moving data is multifaceted, right? It's one thing to deal with things like scale, but then it's another thing to deal with some of the intricacies that come in there, right? Sometimes it's great when we can control every single format, every single schema, every single protocol, but a lot of times it's just not practical. We don't control everything. We deal with other systems, other organizations, whether it's internally, externally, or even globally, right? And so think of that courier example. There's a kind of a wide swath of places where data happens, formats it comes from, devices that we're using, and it's got to get bubbled up to us somehow because we want to look at it and use it and understand how our business is performing. NiFi itself is a framework, but also comes with a lot of great tooling to get you started. So think of like the Swiss Army knife utilities you'd expect, things that do some text replacement, updating, routing, that kind of stuff. We'll provide all of that. But then we also provide the hooks and API to extend the platform as you need it. So if you want to provide your own tooling for your custom proprietary format that's in your organization, cool. Make use of your library you have right now, wrap it in the NiFi framework, and you get all the things like provenance, that unit of work transactionality as things move from point A to point B, built into the framework with the nice UI and the associated properties that are with it. Finally, we're about empowering folks to manage infrastructure without having to get too into the details. When you have those kind of bad smells of Dataflow, where we have that script that's feeding this buffer or what have you, that's being read by another script or application, it gets hard to track it all. It's hard to understand how it all kind of relates together. And as long as it works, it's cool, but when it doesn't work, what happens? How do we track down what's happening? So, in the case I was showing before, one example was that processor was currently in a valid state with encryption. The UI was responsive and kind of told me that, hey, something's not right here, you should look at this. So think of other things where I'm trying to make a connection to a broker or something. It's not there. What can I learn about the exceptions that are going on? How can I avoid having to grep through logs on many systems? It gets hard sometimes. User interface and experience was very important. One of the things that always impressed me about NiFi, and I think is super awesome, is that the user base for it is quite large, right? There's not a huge curve, and I hope that you'll see when we go through the crash course that starting up NiFi is literally just double-clicking a file or running one shell file, right? It's up and on, and you have a canvas, and you get all this functionality. I'll avoid cliches about tech-savvy grandmas and grandpas, but it's kind of cool that people can do tangible and real things with this kind of tool, and it scales up pretty nicely to do some very impressive things in a kind of way that makes sense. Here's some details about the Apache NiFi community. We're located at nifi.apache.org. We have a couple mailing lists. If you have ideas, if you use something that stinks and you'd like something better or wonder if there's a way to do something, file a JIRA out there. We pride ourselves in being kind of a welcoming open source community and kind of embrace all of that. So definitely scope us out there.